This time I will present our product entitled Real-Time Predictions of Surge Pressure Gradient in Drilling Operations. The inventor for this developer tools is myself, Dr. Syahrir, Stiwan Krishna, and also Dr. Suhaib. This is a new and robust tool to predict surge and swab pressure gradient while drilling in real time. It also detects the type of fluid models used for drilling the oil and gas wells. This particular tool is developed by analytically combining the fluid flow physics and mathematical strategies to predict surge and swab pressure gradient. As you can see in the figure, the point A, the locations is analyzed, where this fluid flow physics during tripping operations is applied. And the figure part B shows the annular geometrical arrangement along with fluid flow configurations of non-Newtonian fluid. Here a payment slip is shown of the application field in the My IPO for copyright, which is a tangible property of this tool. In total, 5 research articles are published, 3 in ISI or Scopus journals, 1 in conference proceeding, and 1 in book chapters. Title of all these publications is presented for references. There are numbers of new technologies have been developed by oil and gas industry such as slim hole drilling and calcium well drillings, among others, which are prone to have well control and integrity anomalies that affect the efficiency of drilling operations and its economic viability. These anomalies are raised due to unbalanced and uncertain pressure differentials in the wellbore, which is also called as a surge and swab pressure. Hence, pressure monitoring while drilling is quite crucial. This phenomenon is well described in the figure, which illustrates the tripping in and tripping out conditions under tolerable formation pressure. And the solution for this problem is to predict surge and swab pressure gradient in real time with drilling pipe tripping and cleaning operations, and it will reduce the occurrence of this issue. Simultaneously, tolerable surge and swab pressure will detect the possible highest tripping speed to reduce the non-productive time encounters during this operation. In this slide, we will show a global study of around 380k wells reveal that approximately 26% of wells face well control integrity problem, which account for $1.3 million per day. Also, an analysis of non-productive time taken by various anomalies shown in the bar graph. It shows that 3 anomalies, namely well control, well integrity, and low circulations, result due to a borehole pressure differential, took about 6, 7, and 9 days respectively. The due diligence was carried out to identify the shortcomings in the existing tools. Basically, the existing tools did not consider the effect of mud clinging constant and offshore rig heaving motions, which further result in increasing the surge and swab pressure. Also, most of the tools did not consider the yield power law fluid model in the prediction. In the industry, this type of fluid model is used to develop the drilling fluid. Novelty of this tool are, it requires only 6 input of rheological and geometrical parameters to predict the result. The ultimate surge and swab pressure gradient predictions will increase the efficiency of the tripping operations, which subsequently reduce the non-productive time and also invisible lost time. This tool can universally integrate as an add-on in the rig site drilling console for its direct use by the drilling engineers in the real time, and also in the real-time monitoring center for monitoring. The developed tools is at TRL5 prototype construction stage. The graphical user interface or GUI for automations of search and swab pressure predictions is developed and compared with experimentals and existing analytical model. As you can see in the figures, error of tool predictions with experimentals and analytical model data is in the range of 6.5%. Now let's see the video showing the process of using these tools presented by one of my team, which is a digital version, so all the required parameters need to be entered to determine the result. Once this tool is attached with the on-site system, it will gather the recent drilling data to predict the result automatically. This tool follows the algorithm developed in this aligned study.
Here we have case study example of how the prototype prediction tool product works. It has a graphical user interface application. It works on multiple input parameters and 2 output parameters. For example, let's give the values. Yield point value, let's say 7.8. Fluid consistency index 2.25. Fluid behavior index 0.67. Outer diameter of the pipe 0.045, diameter 0.07, pipe clipping speed 0.12192. Now click on this button to predict the differential pressure, which is also termed as search swab pressure gradient. The other parameter we can identify is the fluid model by clicking this button. So here you can see the output values and you can see the model type is yield power law fluid. So similarly, in a very faster way, you can find these 2 output parameters based on several.
It has been found that approximately $500 million per year is lost due to non-productive time. Therefore, a survey is done on daily drilling report of various onshore and offshore wells. Based on the analysis conducted after the survey, a pie chart showing an average distribution of total drilling time among different operations is prepared. It depicts that 20% of total drilling time is lost on tripping, reaming, and cleaning operations. This will be reduced by the applications of these new developed tools. This tool has a potential interest for oil and gas companies, and the revenue can be generated in form of licensing fee. Also, an intensive communications with our industrial partners such as Petronas is in process. Okay, this is the end of sharing the product, and thank you for listening.